Right, 490 is a product of its prime factors. Let me just give you an example of what we mean by that. So, for example, 20 is actually 4 times 5. We can write that as 2 squared times 5. 2 is prime, 5 is prime. That is a product of prime factors. So if you were unsure before you watching this video and you want to have a go at it now, please do. You also need to know your prime numbers, 2, 3, 5, 7. Like typically it's going to be stuff like that. There are of course higher prime numbers that you might need to be aware of. But just once you get a number, just think, is it prime? Otherwise, like what goes into it? So let's start this off. There's lots of different ways you can write down your prime factorization. And often people like to divide by 2 each time till they can't, but actually it's just going to take a bit of effort to do 490 divided by 2. There's a quick way. We can just write it as 49 times 10. Although you might not realize that 49 is not a prime number, it's actually 7 times 7. 7 is prime, so I can circle both of these. And 10, I can split into 2 and 5, circle both of those. Those are primes. It's actually these times together, 490 is 2 times 5 times 7 times 7. Sorry, that's what I meant. I meant 2 times 2 here before. You could write it as 2 times 5 times 7 squared. This is known as writing in an index form. It's a bit fancier. You'll be okay with that one. Let me just show you actually, if we had divided by 2, of course you got a calculator here, so it's not going to be so bad, but I'm trying to prepare you also for questions where you don't have a calculator. Okay, divide by 2, you get 245. Now this is immediately it's not even, so I'm gonna have to find another factor that goes into it. And that's kind of what I mean. It's like it's gonna be, it might not be easy to do this. It's not gonna be easy to see that 7 goes into that. The way to do it is to spot that 5 goes into it. 5 goes into any number that ends in a 5. And then I'd probably use a calculator for this bit. 245 divided by 5 gives us 49. Of course it had to, because that's my 7 times 7. And I get a different factor tree, but I get exactly the same answer. Just want to show you one other thing. It's worth being aware of this. If you have one of these types of calculator, you can actually, working is expected. All right. I've got to say that. And I always say, I want you to understand things, not just learn like how to cheat on your calculator, but and it's not cheating, I know, but just using your calculator without understanding it. If you do 490 and then press equals, put it here, then press shift fact, your calculator will actually do all of this for you. 2 times 5 times 7 squared. So you can do it with any number, 360, have a go at that one. Press equals, shift fact, and you get the prime factorization. So definitely worth being aware of in a calculator paper just to check your answer, but I would still expect to see factor trees. This question is on buses. They leave every 25 minutes or 40 minutes. The two of them leave at 9 a.m. What is the next time that buses to Ayrton and Bleaford leave the station together? Okay, there's a few ways you can, I can think of 3 ways you can do this. I'm going to talk briefly about all of them, or some in more detail than others. One way of doing it is to count on until we get the same time. So there's going to be a bus that leaves after 25 minutes, and then going to Ayton, it's going to be 50 minutes, and then 75, and then 100. And to Bleaford, it's going to be 40, and then 80, and then 120. If we can get the same time, then that means we know like 0 and 0, obviously here, that's when they left at the same time. But now I'm trying to get another time the same. So I've just got to keep going. Maybe I'll just add a few to each time. Okay, well at this point, okay, I've got 200. I can actually see that, well, because 100 is in the times table and I'm carrying up by 25, I'm going to get 200 for this one. Let's just be careful though and check it. 175 and then 200. So we all take 200 minutes for them to go at the same time again. Well, 60 minutes is 1 hour. That means 120 minutes is 2 hours. 180 minutes is 3 hours. So 200 minutes is going to be 3 hours and 20 minutes. Of course, we actually want the time, so that's why I need the hours and minutes. So I've got 9 a.m. I'm adding on 3 hours. That would take me to 12 p.m. in fact. Then I'm adding on 20 minutes. It's going to be 12:20 p.m. If you don't put the p.m. in, you should be okay. But they are working in like 12, well, not 12-hour clock, but they're using AM and PM, so I'm going to put it in. Second method for doing this question is to do the same sort of thing again, but actually count up the times. So you start with 9, and then it'd be, well, 9:25. This is for I've forgotten the name of it, the one that started with A, Aiton. And then add on 20 minutes, 9:50, and then 10:15. The good thing about this method is that once you got the times, you don't have to then add on the 200. You don't have to turn 200 minutes into time and then add it on. But the disadvantage is it's very easy, I think, to accidentally like not add on the right amount of minutes when you change over the hours in particular. So I'm not going to do the whole thing because I don't actually recommend doing it this way. I just wanted to talk about it. I do see people do it like this. Okay, eventually, I'm not going to do it. It'll take a while. You would get to 12:20. You can just see there's more to write every time. It's not quite as fluid as these. The last method is to realize that we're actually finding the lowest common multiple of 25 and 40. And in fact, a completely legitimate method of finding the lowest common multiple, that is the lowest number in both times tables, is to do what we did here and just list them. But I'm going to show you another way you can do it. I gotta admit, as I'm writing this, making this video, I can't quite remember whether like you could be tested on this syllabus, but I'm gonna tell you about it anyway. Because another way of finding the lowest common multiple is to find the prime factorization of these two numbers. So 25 is equal to 5 times 5, and 40, well, it's 8 times 5, which becomes, this is 4 times 2, and then 2 times 2. So 40 is actually 2 times 2 times 2 times 5. Now, obviously, if you times these two together, it would give you a multiple, but we want a common multiple, in fact, because it's got to be in both of their times tables, but we want the lowest common multiple. And what you can do is you can basically just times the ones that are by themselves. Like you can pair them up is what I'm trying to say. Because 5 goes into both of these, I can just times by it once. If I times them all together, 5 times 5 times 2 times 2 times 5, then of course this will be in both their times tables. But if I just times by one of the 5s, it's still in both of their times tables because this is 25 and this is equal to 40. There's overlap with this 5. So you just have to count, when they're repeated, you just have to times by them once. So it's 5 times 5 times 2 times 2 times 2. And that gives me 25. Oh, sorry, there should be another 2 in there. I missed that out. Sorry, the 40 was from here. But in any case, I'm going to get 25 times 8, which is 200. That's a more advanced way of getting the 200. Now, you might say it's actually just quicker to do what we did here, but when the numbers are more complicated and we get larger lowest common multiples in particular, this method really comes into its own. And sometimes this method is shown using a Venn diagram. I know I'm going into way too much detail here, aren't I? But I'm on a roll, I think. So with the Venn diagram, we put the common factor in the middle. It's shared by both. And I put 5 here, 2 here, 2 here, 2 here. Now, to get the LCM, you just times by each of these. And this automatically causes you to not times by this 5 twice because you just end up timesing by it once. It's in both numbers, but you can see it's equivalent to me pairing it up and then just timesing by it once. Again, timesing these together will give you the lowest common multiple. And the highest common factor, if you're interested, will just be 5. It's the one that's on the inside. Probably for this question, I'd say this one's the best, but I have spoken about a few methods and I want you to be aware of all of them.